Alright, hi everyone, I'm Cheng Tan from PNNL. I'm now giving the presentation about our proposed framework, OpenCGRA, an open source unified framework for modeling, testing, and evaluating CGRAs. So a CGRA framework should contain three main parts: modeling, testing, and evaluating. For modeling, functional level modeling provides the fastest way to emulate the functionality of a target design, and it could also be used as the golden model for verification. Many existing CGRA compilers include cycle-level modeling with cycle accuracy. The register transfer level, also known as the RTL, modeling, is more and more important currently with the open source community growing. It provides the most accurate model and provides synthesizable Verilog to the users. For testing, a robust framework should be able to perform unit testing and integration testing conveniently. OpenCGRA also enables the property-based random testing to speed up the verification procedure. So to perform the evaluation, a CGRA framework should be able to simulate a design, generate corresponding synthesizable Verilog, and perform the area, power, and timing characterization. However, not all these features are exploited by existing frameworks. In contrast, OpenCGRA incorporates all these features into a unified Python-based framework to facilitate the design space exploration of CGRA. Okay, so this figure shows the overview of OpenCGRA, and I'll talk about these three components one by one in this presentation. The OpenCGRA provides a modular architecture design for all kinds of CGRAs. All the basic modules are implemented in a highly parameterizable way. For example, a user can parameterize the functional unit type, the size of control and data memory, the number of registers, and even the network topologies. So all the modules are designed with standard send-receive interfaces, so the user can easily plug in their own design by following the same interface standard. A functional unit could either be basic or complex. A basic functional unit means just like an adder, a shifter, or an ALU. In contrast, a complex functional unit in OpenCGRA is composed of multiple basic functional units, such as a multiplier followed by an adder, to form a MAC unit, which can perform multiplication with addition in a single cycle, right? So all the models and different abstract levels are implemented in Python. So a functional level model just executes every node in the data flow graph one by one until the final branch operation is valid and reached. On the other hand, the cycle level and register transfer level modeling should provide more detailed structural and behavioral information. So in this way, the synthesizable Verilog can be generated finally. So to make a CGRA work efficiently, compiler support is also essential. OpenCGRA provides a heuristic algorithm to enable DFG mapping onto the CGRA. So the CGRA is represented as modular routing resource graph. The novelty here is that our algorithm takes the complex functional unit into consideration. So if there is a complex functional unit in the CGRA design, the corresponding operation pattern supported by the functional unit found in the DFG has the higher priority to be mapped onto that functional unit. So the other operations, probably the basic simple operation like the addition and multiplication, right? They could be mapped onto the other basic functional units. For testing, OpenCGRA extensively apply the unit testing and integration testing. As the figure shows, users need to specify the expected output for each input set. Moreover, property-based random testing is achieved by leveraging the open-source Python-based hypothesis framework which helps you to automatically and randomly shrink your design until the bug is found in a minimum design complexity. This can significantly save the engineering effort in debugging. And showing the code, we can see that the hypothesis can automatically locate or find the minimum combination of the functionalities that cause the bug. So the last part is about the evaluation. We use a set of representative embedded applications to drive the evaluation in this work. Firstly, both the compiler and the cycle-level models can provide the throughput information across all the target application kernels. OpenCGRA can also leverage a bunch of EDA scripts to drive the characterization about the power area and timing. So by doing this, users can get an initial idea about whether the performance is as expected or it exceeds your power or area budget in the design space exploration. We also illustrate a systematic way to design a heterogeneous CGRA. To be specific, we first extract the longest recurrence cycle in the DFG, and then we can design complex functional unit to execute the most common operation chains in single cycle. So this table shows what are the most common operation chains extracted from the representative application kernels. Afterwards, certain tiles of a homogeneous CGRA can be equipped with the complex functional unit to form a heterogeneous one. However, parameterizing functionalities is not an easy work in existing frameworks. Normally, the frameworks are able to allow users to parameterize the number of ports, registers, tails, but not the functionality. Fortunately, OpenCGRA's parameterization system can help you to do this kind of parameterization before the module elaboration. So the code shows only a few lines of Python code can help you to specify the functionalities of specific tiles to form a heterogeneous CGRA. And finally, OpenCGRA can generate the corresponding synthesizable Verilog of your target CGRA design. So here comes the conclusion. OpenCGRA enables the multi-level modeling to facilitate the CGRA design space exploration. It provides extensive test harnesses to test CGRA modeled at different abstract levels. And it can also simulate CGRAs at different levels and generate the corresponding synthesizable Verilog and drive different CAD2 flows to obtain the CGRA power area timing statistics. So besides these takeaways, OpenCGRA is open source and available in GitHub, and welcome to check it out. That ends my talk. Thanks.